Hello and welcome to this AQA Further Math Statistics video, the second in the series looking at errors in tests. And in this video we're going to look at type 1 errors for the Poisson distribution. So if we just remind ourselves about the definition of a type 1 error. A type 1 error involves a rejection of the null hypothesis, and that rejection is incorrect. And that can be thought of as a false positive, that we decide there is an effect, there is a change, but in fact that decision is incorrect. So if we look at a scenario that was introduced in the video that looked at hypothesis testing on a Poisson mean, and we have information here that records show that on average 15 houses are sold during the month of October, and we're going to model the number of houses sold per month in October with a Poisson distribution. And the estate agent thinks that things may have changed, so it's going to record the number of houses sold in October this year and then carry out a hypothesis test to see whether the mean number of houses has decreased. So just imagining setting up the test, we don't actually have a test statistic, but just thinking of our null and alternative hypotheses, that would be lambda is 15, no change, or lambda is less than 15, there has been a decrease. And we're testing at the 5% significance level. So how can we investigate the probability of a type 1 error with this particular test? So this is the setup for our test, and our random variable, which is the number of houses sold in a month in October, is following a Poisson distribution with lambda equals 15. And we want to find the probability that we incorrectly reject the null hypothesis. So if we want to find that probability, what do we need to work out? And you need to bear in mind here that a type 1 error only happens when we reject the null hypothesis. So we need to sort out where and what range of values for x will lead to us rejecting and which range will lead to us accepting the null hypothesis. And that means that we need to find critical values, we need to find our extreme tail, such that the probability of getting that value or less than that value is equal to or less than 5%, because we're testing at 5%, where we have a random variable following a Poisson distribution where lambda equals 15. And just to illustrate what we're doing here, we need to find the maximum value for an outcome so that our probability is less than or equal to our 5% significance level. And if you just have a look here, if we go up to 8, you can see that the probability of getting between 0 and 8 or 8 or less is 0.374, and that's definitely below our 0.05, the significance level. If we go up to 9, that's no good because we're exceeding our 5% significance level. And so our critical values, the outcomes that are possible for x that will lead us to decide on the basis of probability that they're so unlikely to happen that we're going to reject the null hypothesis, are the values 0 to 8. So for a type 1 error, we need to work out the exact probability that our outcome is less than or equal to 8, given that our null hypothesis is in fact true. And of course that's what we use to find that area in the first place, and it's actually 0.0374. And therefore the probability of a type 1 error, the probability we incorrectly reject the null hypothesis, is actually 0.0374. And remember that the probability of a type 1 error is always equal to for continuous distributions, or in this case less than the significance level of the test. And sometimes the probability of a type 1 error is referred to as the actual significance level of the test. It was set at 5%, but because we have a discrete distribution, the closest we can get to 5% and keep below that value is actually 0.0374. So again, if we just set up this hypothesis test, this time our alternative hypothesis is simply that lambda does not equal 15, so this is a two-tailed test at 5%. And remember, with two-tailed tests, we split our significance level at each end, the low end, extremely unlikely low, and the extremely unlikely high end. And again, with a type 1 error, we need to work out the reject H0 regions. And so to find the probability of a type 1 error, we've got to identify our 2.5% extreme critical tails that will lead us to reject the null hypothesis. And so therefore this time we need to look at the low end a maximum value, where to get up to and including that value we keep below our 2.5% significance level for that tail, and a minimum top value such that getting that value or more is also less than 2.5%. And we need to look at that where our random variable follows a Poisson distribution with mean 15. And so bearing in mind that each tail must have a probability less than or equal to 2.5%, you'll find, if you work this out on your calculator or using GeoGebra, at the low end 7 is our cutoff point, and the actual probability there that keeps us below 2.5% is 0.018, and at the top end it's 24 or more. So if we obtain an outcome for the number of houses sold in October of 7 or less, or 24 or more, we're going to reject our null hypothesis. We're going to say, on the basis of evidence, we believe that there has been a change. And again, at the top end, at 0.0195, if we go any further, we're going to exceed our 2.5%. And therefore the probability of a type 1 error for this two-tailed test is actually going to be the sum of the probabilities of falling in each tail, and that's 0.0375. So that's the probability of our type 1 error, and I said sometimes called the actual significance level of the test. And that concludes this video.